Okay, from today we are going to discuss about the Humphrey field analyzer or Humphrey automatic perimetry or whatever you call it. I call it AVF automated visual field. Sometimes it's called SVF Humphrey visual field. Doesn't matter. We start from today. It will take maybe 10 videos. I don't know. Let's move and let's discuss. So automated perimetry, as we have discussed already, in many chances, it's computer assisted examination, and definitely it's not fully automatic. Patient's response matters. And field testing strategy is mainly static. We know it. It's not an dynamic. Yeah, definitely we can do dynamic test from this, and it's definitely pre-selected field where we put the target and we define the threshold. And today's video is going to be completely on threshold is the main topic of today's presentation. Yes, there is Humphrey, octopus, decon, topcon perimeters. There are a lot of, but Humphrey is a gold standard, and Humphrey we are going to talk about Humphrey for maybe 10-12 videos. Okay, so what is the difference, gross difference between octopus 300 and Humphrey 700? In October 300, direct projection, but in case of Humphrey, there is a ball and we project in the ball. Background illuminance is approximately same, 31.4 apostable, 31.5 apostable. Stimulus in case of octopus is Goldman 3 and 4 size. In case of Humphrey 7, 1 to 4. Okay, duration of stimulus presented 100 millisecond in case of octopus. In case of Humphrey is 200 millisecond. Great difference, which is 0 decibel. That means the highest stimulus intensity that can send is octopus 300 is 4800 apostable, but at the same time Humphrey 700 is 1000 apostable. That's a great difference. Measuring range 0 to 40 decibel. Yes, definitely 0 to 40 decibel. Strategies are these, and we will definitely going to talk about Humphrey and a lot of strategies that Humphrey used. This is simple thing. Age rated year is calculated in optics octopus 300. So let's move, just discuss about few hardware and software things. Okay, in case of Humphrey we are going to talk about Humphrey, we are not going to talk about any other perimetry. Okay, so hardware consists of balls, optical system, central processing, and the patient's interference. And the ball is definitely spherical bullet shaped. Distance approximately eye from boy is 30 centimeter, and ball is perfectly matte, that is Lambertine surface. You will know about it, and I have already discussed about it in photometry. Optical system stimulus present aiming at a particular location to be tested. We have to know the particular location and we will test definitely. Then the central processing is the same as desktop computer and must control the optical system by the computer system, and split second strategy adjustment based on the each patient's response. According to patient response, so computer adjusted and presented the stimulant. So the patient interface consists of chin, forerest, trial lens holder, table, chair, is this all things. And trial lens holder used to hold is 33 ophthalmic trial lens, which is large trial lens, that and which is never used for test outside of 30 degree, because outside of 30 degree it will create artifact, that artifact is known as lens rim artifact. Okay, so within 30 degree we use that stuff. Today's video is completely going to be in the definition of threshold. We are going to discuss on threshold. Okay, see what is not threshold is this, and many of the students think like this. Threshold is the visual threshold is often thought as a minimum brightness which the patient can see at a given location in the same field. It's not that the definition of threshold. So it is very important to have a clear concept on what is threshold, what is supra threshold, and what is infra threshold. See, this graph will make you clear. In y-axis it's frequency of seeing, how many times seeing is this. In x-axis we can see decibel of light intensity. So suppose example, in this example we present 100 times a particular stimulus, then threshold is 50 times when that stimulus is seen out of 100. That is threshold. If less than 50 times that stimulus is seen, particular stimulus, then it's infrathreshold. Or more than 150 times that stimulus is seen, that is suprathreshold. Okay, let me make you clear one more time. Okay, wait. See, this is retina. Okay, this is optic nerve, And suppose this is phobia. Suppose in this point, particular point, we present one stimulus, suppose 20 times. Then out of 20, if it's seen correctly at 10 times, this is called threshold. If out of 20 it's seen correctly 15 times, it's called supra threshold. Out of 20 times it's seen only 3 times at this particular stimulus. It's but at this particular area, and this is called infra threshold. That's the concept of threshold. Just remember, this graph is very important. Okay, so threshold, we know threshold. Okay, then it there is a term that is light intensity and retinal sensitivity. These two terms are very intertwined, and students don't know about these terms and about this concept. It's very important. Okay, light intensity and retinal sensitivity. See, light intensity is a photometric value, isn't it? We have already discussed about apostable candela per meter square, isn't it? So apostable is converted to decibel. Apostable is actually absolute unit. Decibel is convertible unit. So in case of our hearing, isn't it? It's decibel. Okay. So decibel is convertible unit. Actually, what is decibel? Is 1 decibel is, this is very good line, 1 by 10th log unit of attenuation of maximum available stimulus. What is maximum available stimulus in case of Humphrey visual field analyzer? Isn't it 10,000 apostable? What we have discussed earlier. So 1 decibel means 1 by 10th log of maximum available stimulus. So that matters. Okay, that matters. That's called 1 decibel. It really matters. In a Humphrey system, 40 decibel stimulus is equals to 1 apostable, and 0 decibel stimulus means 1000 apostable. I'll make it clear, but currently you feel like what is this? But like, don't worry. So apostables are absolute units of light intensity. Suppose my tab has certain apostable light throwing, or your torch light, or AVF, it doesn't matter, or your computer, it doesn't matter, or the lamp, it doesn't matter, because that apostable is equal to my tab's apostable. But decibel, definitely relative units. For example, we have discussed about the octopus, where the maximum intensity is 4800 apostable. At the same time, Humphrey is 10,000 apostable. 1 decibel of octopus 300 is not equals to 1 decibel of um, Humphrey 700. But 1 decibel is 1 decibel. But at the same time, apostable is not equal. It's just 1 decibel. 1 by 10th log unit of this, and 1 by 10th log unit of this. So that's very important to understand. Okay. So conversion from the apostable unit, which is absolute unit, to decibel is logarithmic. And just remember, not a simple multiplication of factor. It's very important. Okay, apostable and the decibel, it's very important. Decibel depend upon the maximum intensity that machine can throw on you. Apostable is just an unit. It doesn't matter whether 100 unit from the I don't know, from tab, or 100 unit from the lamp. That's 100 unit apostable. Okay, so see, a small shift in decibel scale represent the major change in the intensity of the light in terms of apostable unit. That's very important. See, if decibel, and that's exactly opposite thing. 0 decibel means the highest possible apostable that throws on the light, throws on the eye, isn't it? That's why 0 decibel you see always on the optic nerve head. The optic nerve head, there is blind spot, no matter what, no matter 10,000 or 1 lakh apostable intensity you throw on the optic nerve head, it won't be detected, isn't it? So 0 decibel means 10,000. So just increasing 10 decibel, it divided by 10, and again add 10 decibel, divided by 10, 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 isn't it? Isn't it? So, basically what I am talking about is the small shift, even just 1 decibel increase from 0 to 1, it's definitely a possible reduces. Okay, so it's very important to understand that how this functions, how this skill set functions, and this is a very important slide that you have to understand. From decibel to apostable, isn't it? Highest the decibel, smallest the decibel is apostable light, but at the same time, highest the decibel, highest the retinal sensitivity, isn't it? So, so important point to be noted that decibel unit represents both light intensity of the machine at the same time retinal threshold value. People don't understand this concept. Okay, let me clear it. So 0 decibel means when used to express light intensity of what? See, the maximum intensity of light is projected to any perimeter level as a 0 decibel, because 0 decibel means the maximum intensity of light that is thrown. In case of Humphrey, 0 decibel means 1000 apostable, but in case of octopus 300, 0 decibel means 4800, isn't it? Isn't it? So that's what I am talking about. See, 0 decibel in octopus 100 and 101 is 1000 apostable. 0 decibel in octopus 1 to 3 is 4000 apostable. But in case of Humphrey, it's 10,000 apostable. So it actually varies from the machine to machine. 0 decibel means. But apostable, 1000 apostable in Humphrey or 1000 apostable in octopus is always 1000 apostable, isn't it? So that matters. Another thing is, when used for the retinal sensitivity, Humphrey field analyzer, when maximum intensity of 1000 apostable unit is not perceived, it is labeled at 0 decibel retinal sensitivity. Means retinal sensitivity is 0 decibel, absolutely 0. Therefore, 0 decibel indicates the absolute scotoma. And where we can find absolute scotoma? Definitely in blind spot, isn't it? In blind spot, it doesn't matter if absolute intensity of light is 10,000 or maybe 1 lakh. Okay, because there is no photoreceptors, it's absolute scotoma. So see, this all these graphs I have taken from this book, G.D. Reddy's Practical Guide to Interpret Visual Field, 3rd edition. And let me tell you, just grab this book. This is the best book I have seen for the Humphrey. It's perfect. It's perfect. I recommend you highly. Just buy this book and read. So let me clear you from this graph. Okay, what happens? What do you mean by low value decibel? Suppose example, low means not 40 but means 0, 1. It means less attenuation of light intensity, which results in the projection. Means the higher light intensity we are projecting, because low decibels means high projection, which means high intensity of light stimulus given, isn't it? 0 decibels means 10,000. And then which means if retinal points respond to the high intensity of light stimulus, indicates what? Retina has low sensitivity, isn't it? You have to stimulate retina by highest decibel. Then what do you mean by that? Retinal sensitivity is low, isn't it? Threshold and the sensitivity is both opposite thing. So low value indicates high light intensity, at the same time low retinal sensitivity. Again, high decibel value indicates low light intensity, which means what? High retinal intensity, isn't it? Exactly opposite. Can't you think like this? Opposite. If it is low, then it must be, if it is high, it must be low. And if it is low, it must be high, isn't it? Just think about it. Okay. So the main disadvantage of expressing retinal sensitivity in apostable unit is that retinal sensitivity is inversely proportional to apostable value, isn't it? For example, optic discs. If you talk about optic discs, then you have to write optic discs as a 10,000 apostable, and it's isn't it just inverse that we have to think higher the apostable means the bad. But the main advantage of expressing retinal sensitivity in decibel unit is that retinal sensitivity is directly proportional to the value of decibel. So means if you know optic disc, 0 because dead. Yes, and scotoma, relative scotoma 10, maybe absolute scotoma, then it's 0. Isn't it beneficial? Sometimes you see 30 decibel means wow, that's good sensitivity. Some, yes, definitely for the macula, yeah, 37, 30, 36, isn't it? So that's the main advantage why you use decibel unit. And another example is you have to write 5 digits at the same time. You can write in one single digit or 2 digits maximum. Another benefit, isn't it? So in conclusion, just see this chart. It's very good chart. This is stimulus intensity, this is retinal threshold, and this is fall of retinal threshold. See, if you move from one apostable to apostable, it means you double it, isn't it? It means you double it. Then how much decibel reduced? 3 decibel is reduced, isn't it? So it's very important to know that stimulus increases, retinal threshold decreases, and 0 means maximum that instrument can project, which is 10,000. And whenever you add decibel, it means it definitely reduce. You keep on adding 10, 10, 10, you are dividing by 10, 10, 10, 10, isn't it? So at least from this graph you know to just increase, double the intensity from 1 apostable to 2 apostable, it means you are reducing by 3 decibels, isn't it? That's fascinating. So this is very important to understand what is threshold, how threshold works, how stimulus intensity is working. So it's very important, this concept should be clear. Okay, so I highly recommend these two books. I have read these books in my bachelor's. This is great book, but my goodness, this is great book by G.R. Reddy. Just grab this books if you want to understand visual field. It's very clearly written. Okay, and my best recommendation is will be Practical Guide to Interpret Visual Field by G.R. Reddy. It's a very good book. Okay, so I will definitely going to talk about this book more and more, but be conscious.